So my name is Igor Lovich, and I'm a technical lead at Société Générale Corporate Investment Banking. So just to give a bit of a background, what's the business, right? So the applications that my team provides to our end users, who are bankers, client coverage teams, back office, and risk, are primarily aimed at loans, right? It could be very big loans, it could be small loans, but in general, it's large loans to corporate clients. Things like financing infrastructure projects, aircraft leasing, shipping. This is a highly regulated activity. There are auditing requirements, compliance requirements, and typically we have user-facing applications, right? As opposed to market-oriented activities where there's a lot of automated systems, right? So we started off with 2 or 3 legacy systems, or there are more, which were very resistant to modifications. They were hard to modify. Delivering them into production was complicated. Automated testing was very complicated. Users complained they were slow, right? Everyone's probably familiar with these kind of problems. So back in 2015, there was a transformation project which was undertaken. And the business goal, right, was to simplify the platform for the users, right? The goal was to have a single platform which will abstract away all the complexity, all the IT complexity behind the scenes. So microservices, legacy systems, the end users don't care. All they want to see is a single application with a consistent flow. We'll try to make these applications intelligent, right? So it's not just basically applications which help the users do their job. They're not just systems for inputting data. And from the IT side, we wanted to be more agile. We wanted to be able to deliver value faster. In the legacy environment, the applications were delivered on a schedule from about 3 to 4 months, every 3 to 4 months. Our goal was to deliver, at worst, every 3 weeks. And so at the end of every sprint, we deliver. If you deliver frequently, you cannot afford downtime. With legacy systems, we would tell users there's a planned downtime for an upgrade. You cannot do that every 3 weeks, right? So we had to be able to deliver with 0 downtimes, and it also focus was on APIs. So we're not just, the front end is just one of the consumers of our APIs. Other systems can consume them as well. So we have a complex domain. We have auditing requirements. We also have as-of requirements in some cases. We need to be able to reconstruct a state of business object at a certain point of time. So we decided to attack them using DDD, event sourcing, and since we're using event sourcing, CQRS was kind of a must. So what did we do? At the very beginning, Google search, DDD, event sourcing, CQRS, Java, because we're Java developers, Axon Framework, right? Let's try it. So fast forward to 2017 now. 2 years later, we have, so beside the legacy systems which are still there, we have 15 microservices. 3 of those are using Axon. We have 3-week sprints, and we deliver at the end. Some services are even delivered on demand. So when the developer finishes a feature, it automatically goes through the integration pipeline. It's deployed to a testing environment. The tester's happy. It goes to production. So now I think I come to the best part. When I attend these kind of conferences, I really like to get the feedback of how the technology is being used, what are the advantages, and what are the disadvantages, right? Because when you look at the internet, everything's fantastic, rosy, peachy microservices, integration through messages, right? So let's start with the benefits. Using Axon Framework, the security is easier, right? Because all your modifications of the domain are through commands, which go through the command bus, and Axon Framework provides interceptors, which allows to validate the permissions, the visibility, add auditing metadata, right? Very useful. So we're in a microservice environment, right? So we need events everywhere. In a context of a single microservice, if you're using Axon, you're already event-based, right? So if you want to publish events for integration with other microservices or legacy systems, it's kind of easy and free. One thing we've decided against is to avoid coupling with to Axon. The events which are listened to by other systems, right? They're not the events that are published by Axon. We have event handlers which convert them to external messages, right? So the loose coupling is fantastic. You want to send an email on an event, you add an event listener, you send an email. You want to create a new read model, you add event listeners, right? It's hard to become a big ball of mud if everything is in a separate module and integrated through events. That's the best image I could come up with for a slippery slope. The metaphor there is that with Axon, the slippery slope is on the good side, right? When we're talking about implementing DDD, right? Two very important criteria is separating the business logic from infrastructure, which is even better with Axon 3, and avoiding anemic domain models. Axon forces you to do things correctly. You can try to fight it, usually with poor results. It is a framework, so some people think frameworks are bad. There are advantages, right? Because a framework imposes a certain conformity. When you have lots of different teams working on the same piece of code, right? There is turnover, people come, people go, across different countries. A framework is a way to, suggest people all go into the same direction, right? Also, Axon annotations, they help to document the code. There's a concept of living documentation, right? If you want to see, where's all my business logic, right? But you look at all the command handlers. You see, what happens when there are various events in the systems, but you look at all the event handlers. So when new people join the project, it's a lot easier to navigate. We use IntelliJ at work. There are plugins which allow you to navigate from command handlers to event handlers. Quite useful. So deployment to production, right? We're using trunk-based development with feature toggles. So when we go to production, we don't take a branch. It's always the same code that gets built and gets deployed. If a feature is not ready, it's toggled. When using event sourcing, as opposed to relational models, schema changes are code, right? You're changing your events, and therefore they're easier to toggle. Hope that makes sense to everyone. In Axon, there are text fixtures, so we can test your aggregates using them, which personally I found a fantastic way to test your aggregates. You treat it as a black box, and your commands come in, events come out, and you just test the behavior, right? You don't really care about the internal state of the aggregate. The documentation is great. There are some people who roll their own CQRS frameworks or event sourcing. It's not really difficult to do poorly. It's difficult to do correctly, but it's even more difficult to do correctly with great documentation. The community is very active. I think Michael mentioned it previously, that Allard answers questions very quickly. That's very important when you have a problem. Another thing which was very interesting, sometimes you have problems in production, and you want to be able to reproduce the problem in a non-production environment, whether it's a developer machine or a testing environment. With a relational model, if you want to export the data for some business object, sometimes you have to export 10, 20 tables. When you import it, you have to worry about constraints, and it's a pain. When you're using event sourcing in an event store, you select the events that are related to your aggregate, you export them, you import them, and you're done. Some of the lessons learned, sometimes the hard way. So we're organized in feature teams, right? Not component teams, so we're client-oriented. So that means that different teams, when implementing a feature, are going to touch code bases for different microservices. And we found that the skill levels vary wildly, right? It could be in terms of knowing a certain technology, like Axon. It could be in terms of knowing a philosophy, like DDD. So our solution was to actually name service owners. So we have teams which are responsible for certain services for the code base. So all the modifications, all the pull requests have to go through them. they need to do the code review and validate, right? So the commit modification, the commit privileges to the service Git repository are limited to the service owners. Next, so we store our event store in Oracle, which is basically a bunch of blobs, and we create read projections in Elasticsearch. Our business analysts historically have experience with relational models and SQL. When they do their business analysis, sometimes they like to go around and look at data and do select queries. Very difficult to do when you have an event store. And they don't know how to do a node script in a JavaScript and execute against Elasticsearch. So it's a problem. A long-term solution, we could do a relational projection, but it means it's something else to maintain and an extra cost. We haven't gone that route. Long-term solution is a data lake that's being put in place, which will aggregate all the events, which will create a projection which is easily queryable. For now, we do some queries using XML in Oracle against the event store based on the needs, or some Node.js scripts to query Elasticsearch. Something that was not anticipated. So we're using Spring Cloud with service discovery, all that wonderful stuff. This is a snapshot of our console registry. So we have a command side, query side, running separate processes. They get registered as two separate services in console, right? Not ideal because it kind of leaks your internal architectural choices to the outside. So far, we haven't found a good solution to this. Sometimes, for one service, what we've done is we've just merged it into a single process because scalability was not a factor. If you have a solution, we're welcome to hear it. We want to have small and flat business events. If you find yourself with events, something saved event, something updated event with 15 fields, normally means you have two problems. One is that event sourcing might not be the best thing for you. You're probably doing just CRUD. You've lost the intent of what the user wanted to do. And two, when events are large, as time goes on, there's more and more chance that these events need to be changed. And changing events and schemas in event sourcing is not free, because you have the whole history and everything, right? We're using Axon 2.4. I don't know if it's still the case with Axon 3, something that we've learned the hard way. Do not store complex objects in metadata. There is no mechanism to upcast them as you go from one version to another. And store only what you need in metadata. A lot of times people would go, we'll just store everything. Maybe we'll need it, maybe we'll not. Every time you read an event, Axon needs to deserialize the metadata as well. That has a cost in terms of performance. Another problem is the lack of tools in dealing with event store, right? So our event store is an Oracle table with blobs. In theory, your event store is immutable. Things have happened. If you want to change it, you apply compensating events. In practice, when you have a production problem and you want to undo something because of a bug, yes, you can insert a new event, which you have to create manually, or you can just say delete from where event ID equals this, right? Not the best thing, but when the business says, it has to be solved now, there are trade-offs, right? So typically in terms of tools, it has been kind of roll your own. Maybe with the new event store, we'll have something better. But currently, it's kind of it's a bit of a pain point for us. The event handlers, right? Something which people might not think about is idempotence, right? When you have a distributed event bus, something like RabbitMQ, you need to worry about the broker semantics. How does it deliver your messages? RabbitMQ, for example, that we use, it guarantees that the message will be delivered at least once, right? It does not guarantee that it will not be delivered 2, 3, 4, 5, 10 times. This may be a problem, right? If your event has information, something like deposit 10 euros on the account, right? And this gets replayed 5, 6, 10 times, this is a problem, right? So the way we've managed this, for some events where this was important, we would transfer the state as well as the delta, right? So if you go back to the event, back to the example that I've used, we would say that deposit 10 euros on the account, but also say that the new account balance is 10 euros, the old account balance was 0. This might or might not work in your scenarios, but something that you need to think about. The second issue that we've encountered, race conditions, right? Well, I hope I don't need to explain the joke, yes? So Axon provides a mechanism to order your event, to order the order in which the event handlers are invoked, right? Using clusters and order resolvers. That's fine. However, if you have a command which gives rise to multiple events, right? And you're using a distributed bus, and you have, for reliability purposes, you have multiple instances of the same event handlers running, you don't know in which order those will get picked up. And so one instance can be under heavier load, so you could process things slower. So you have race conditions. So it's something you need to think about. This may or may not be a problem. Can I still read my event store? You put your Axon-based microservice into production, everything's fantastic. 2 years later, 2,000 commits later, can you still read all of your event store? You don't know. So you don't want to find out in production. We found out in production that sometimes the answer is no. So what we've done, we've made it part of our continuous integration. Depending on the size of your event store, you might not want to schedule it on every pull request. You might want to schedule it once a week, once a month, but the only way to be sure that you can read all the events in your store is to actually read them and try to deserialize them. So the CQRS command events in user-facing applications for us was very difficult because making task-oriented UIs is difficult, especially when our clients, historically they're not IT, they see IT as a constraint for the most part. They like to work with Excels, right? So when they ask for solutions, typically they want to see, well, I just want to specify, you have 300 fields, I want to enter them, and I just want to click save at the end, right? This is the problem if you want to capture intent and have events which have value. So sometimes we've tried to deduce what the intent was, mixed success. The goal is to have task-oriented UIs. Haven't been very successful with that, but we're trying. So I think this has been mentioned already, but I would like to bring it down more to Axon. Axon is a framework which provides different implementations for different aspects. There is a simple command bus, distributed command bus, there is a disruptor command bus. You can do your event handlers synchronously, asynchronously, snapshots, caches. Sometimes developers, they try to anticipate problems before they arise, and they're going to think, wow, fantastic, when they build this super huge scalable system, they can handle 10,000 requests per second, but they don't really need that, right? So for our first service using Axon, we did everything that Axon allowed us to do, right? So we could probably handle, so if you remember in my previous slide, I've mentioned that we have 4,000 users. Of those, there's about maybe 50, 60 which are active concurrently. In terms of number of requests per second, about 100. We could, with the first microservice that we put in place, we could probably do 100 times that, but we didn't need to. But the complexity is there. When you do things asynchronously, it's more difficult to test. It's more difficult to maintain. Don't do it. Pick the simplest thing. Pick the simple command bus. Pick the synchronous event handlers. No caching, no snapshots. And if you need the performance, you see that there's a performance bottleneck, you can add that later, right?
So I was just curious whether you could elaborate more on how you, what do you mean exactly by converting internal events to external events, as you mentioned earlier?
So we have each microservice, right? It has a distributed event bus, which is basically a RabbitMQ bus, which is private to the microservice. Other microservices are not allowed to listen to the events that transit on this bus, which are Axon events, serialized Axon events with metadata. So what we do is we create a listener which listens to the events that we want to publish and share with the outside world. And we just, it gets published onto a different messaging bus. There are two advantages, is we're not exposing the Axon internals in terms of metadata, how things are serialized. The second advantage is that we choose what we publish, right? Because when you're in event-sourced world, you can choose to publish everything, right? But your events are your interfaces, The moment something's available, somebody's going to latch into it, and it becomes that much more difficult to change later on. I think there's a question over there.
I heard you say something about problems or issues with ordering of events.
Yes.
Have you guys considered looking into something like Solidity or a different type of blockchain technology to utilize this mechanism, or even use it as an event store itself?
We thought about it, but we never actually did it because, as I think the previous presenter mentioned, for us the value, right? Our value added is the business logic. Like every second that we spend working on infrastructure, right? Although it might be fun, the business doesn't care, right? So if we can avoid writing our own event store, right? And integrating with something else and having another piece of infrastructure to maintain, we choose not to, right? So we try to find solutions another way before we try to bring another piece of technology into the stack.
I guess we can stretch it to have one more question. Well, I guess that's exactly on time. Please give Igor a big hand. Thank you very much.
Thank you.